we're going to use our circle properties to find the measure of some missing angles. In this question, we're asked to find the missing angle measures x and y. So first we need to identify those angles. Angle x is right here. That angle has measure x. And the angle with measure y is right here. So there's our angle with measure y. Now we also have a third angle in our picture. That angle measurement is given. It's 20 degrees. So that's pretty much all the information that's in the picture. So now we need to start looking at how can I use that information to figure out my missing measures. One thing that you need to look at is that all of those angles have something in common. They're all subtended by the same arc. And what that means is if I was to start and trace angle y, if I begin here and come back down, I have chopped out this arc in the circle. If I do the same thing with my green angle, I chop out that identical arc. And likewise with my black 20-degree angle, I'm chopping out that same arc. So what we say is that all those angles are subtended by the same arc. And we have a property that we can use for angles that are subtended by the same arc. In a circle, the measure of a central angle, in our case, our central angle is our green angle. A central angle has its vertex at the center of the circle. So we have a central angle right here. It's going to be twice the measure of any inscribed angles that subtend the same arc, are subtended by the same arc. So I have two angles here that are subtended by the same arc as my central angle, and I'm told that my central angle will be twice their measures. So one of those angles I'm actually told the measurement of, I'm told that it is 20 degrees. So I have a 20-degree measurement right here. So that means my central angle x is just going to be twice that inscribed angle. Twice 20 is 40 degrees. And for angle y, there's a couple of things I could use. I could use the fact that I already know now that the central angle is 40 degrees, and that's twice any inscribed angle subtended by the same arc. So I could use that to help me out and say, well, if 40 degrees is twice my y, then y must be 20 degrees. Or we have a second part to our property that we could use, and that is that because of that first property, any inscribed angles subtended by the same arc are also going to be equal. An inscribed angle is an angle that its vertex is on the circle. So I have a vertex on the circle here and a vertex on the circle here. So these two angles are actually equal. So I can either use the fact that my central angle is twice my inscribed angle and say, well, 40 is twice 20, so that must be 20. Or I can say these two angles are inscribed angles subtended by the same arc, so they must have the same measure. Either way, I know that y has a measure 20 degrees.